Here is a number pyramid. The number in a box is the sum of the two numbers below it. Write the missing numbers. And we can see how this works because here we have 290,000 and 200,000 plus 90,000 makes that total. So really we have some missing number problems. 290,000 plus whatever this box here is equals 500,000. So when we have a missing number addition, we can subtract to find our missing number. So we can work out 500,000 minus 290,000, and that will give us this box here. So our answer is 210,000 because 50 minus 29 is 21, and then we keep our 4 end zeros. So we have 210,000. If you can't do this mentally, then of course you can use column subtraction to get your answer. So now, knowing that this box is 210,000 will help us to work out this box here. We have 90,000 plus whatever this box is equals 210,000. So again, it's a missing number addition, so we can subtract to find our missing number. 210,000 minus 90,000 is 120,000 because 21 minus 9 is 12 and we keep our 4 end zeros. So we get 120,000. Draw the reflection of the shaded shape in the mirror line. So when we're drawing a reflection of a shape, what we can do is dot the points that are the corners of the shape or the vertices and then join them up. So if we take this point here, to get to that from the mirror line, we go across a half and then 1. So from the mirror line, in the other direction, we can go across a half and then 1 and dot the point. For this point here, from the mirror line, we go across a half and then 1 again. So we go across a half and then 1 in the other direction and dot the point. And that makes sense because you can see that this point here is directly below this point here, and that's what we have in our reflection as well. Now to get to this point here from the mirror line, we go across 1, 2, 3. So let's go across 1, 2, 3 in the other direction and dot the point. And now our last point is on the mirror line, so it will be on the mirror line in our reflected shape as well. So now all we need to do is join up the points and we have our reflected shape. Here are some shapes on a 1 centimeter square grid. Write the letter of the shape that has the smallest area. So the question says that it's a 1 centimeter square grid, but of course, depending on the size of the screen you're watching this on, 1 square won't necessarily be 1 centimeter here. And also on the question paper that I've given you, the question's been scaled down, so your grid is less than 1 square centimetre. But if we imagine that these squares are centimetre squares, then to find the area, we're finding the amount of stuff inside the shape, so we can do that just by counting squares, because the area is how much space a shape takes up. So for shape A, we can count 6 squares. Now, if we look at shape B, in the part that I've highlighted, you can see that this takes up half of 2 squares. And if something takes up half of 2 squares, then it's the same size as 1 whole square. We can imagine this part that's shaded in the top square is the same size as this part that's not shaded in the bottom square. So the part that I've highlighted here has 1 square, and this part here has 1 square as well. So because that's 1 square, and we have 4 squares in the middle, shape B has an area of 6 squares as well. For shape C, we have lots of half squares shaded, but remember 2 half squares will make 1 whole square, So we can count 1, 2, 3, and then we have 4, 5. So the area of C is 5 centimeters squared. For shape D, if we look at this part that's highlighted, we can see that it's half of 2 squares, so that's 1 square. That's another square altogether, because again, we have half of 2 squares. And then we have these 2 half squares at the top, which will make 1 whole square. So we've counted 1, 2, 3, and then we can count 4, 5, 6. So the area of D is 6 squares. And we can see that the area of E is 6 squares as well. So that means C has the smallest area because it only has 5 squares shaded in, but all of our other shapes have 6. Draw 2 lines on the square below to make 4 triangles that are all the same size. So because it's a square, and a square has sides of the same length, all we need to do here is join the corners, and then we've made 4 triangles that are all the same size. This wouldn't work with rectangles, because in rectangles 2 of the sides will be longer, but for squares, because they're all the same length, to make 4 triangles, we can just join up the corners. Now, draw 2 lines on the square below to make 4 squares that are all the same size. So this time, the 2 lines that we want to draw have to look like this, because that way we've made 4 smaller squares. And it's important that the lines are drawn down the middle of the shape, so that we have the same length on both sides of where we've cut it. So this length here has to be the same as this length here, and you might need to check with a ruler, and also this length here needs to be the same as this length on the other side, and so on. A pack of 20 postcards costs £3.60. A single postcard costs 20 pence. Zach buys 1 pack of postcards. Jade buys 20 single postcards. Zach says to Jade, "My postcards cost 40p less than yours." Is he correct? Explain how you know. So we know that Zach buys 1 pack, and 1 pack costs £3.60. But to see how much Jade spent, we need to multiply 20 by 20 pence, because she bought 20 20-pence postcards. 20 times 20 is 400, because 2 times 2 is 4, and then we have 2 end zeros in the question, so 2 end zeros in our answer. And 400 pence is the same as £4, because 100 pence is £1. Now, Zach spent £3.60, so if we find the difference, we can work out the £4 that was spent by Jade minus the £3.60 that Zach spent, and that means we have 40 pence less spent by Zach, so Zach is correct. And this question says, explain how you know, but we don't need to write in sentences or paragraphs. We've explained using numbers and just a little bit of writing, so we should be able to get the mark for this question without having to write what we've written again, but in words. Match each percentage to its correct decimal equivalent. So we need to remember that a percentage is a fraction with a denominator of 100. So 5% means 5/100ths. And we also need to remember that with decimals, the 100ths digit is the second digit after the decimal point, because the first digit is the 10ths digit. So that means we can match 5% to 0.05, because 5% and 0.05 both tell us that we have 5/100ths. With 0.5, we would have 5/10ths, not 5/100ths. Now we have 55%, so that's 55/100ths, which as a decimal is written 0.55, because remember, we can only have 1 digit in each place value, So the first 5 in our number gets moved over to the tenths. Remember, digits move left when there's not space for them. So 55% is 0.55. Now we have 40%. We can match that to 0.4 because remember, with decimals we can always put a 0 on the end. So 40% is 0.40, but normally when we're writing decimals we don't write the end 0. And that makes sense because we can simplify 40% or 40 hundredths to 4 tenths, and if we have 0.4, that's the same as 4 tenths. We have the digits 2, 4, 6 and 8, and we need to use all 4 digit cards to make this number sentence correct. So something times something is greater than 5,000. So we want to make the largest number possible, and that means we want to have our highest digits as our tens digits and our smallest digits in our ones. So we can write 8 and 6 as our tens digits, and then the smaller digits, so 2 and 4 as our ones digits. Then we can check that 82 times 64 gives us an answer that's greater than 5,000. And when we do the column multiplication, we get 5,248. Now this is a multiplication, and remember, with multiplication, order doesn't matter. So we could have written 64 here and 82 here. But there is another possible answer. If we work out 84 times 62, we get 5,208. So we could switch our ones digits, and again we could have 62 times 84, so with the numbers written the other way round. Also, it's important to notice 82 times 64 does not give us the same answer as 84 times 62. Of course, if we were adding these numbers, we would get the same answer, but it doesn't work for multiplication. This shape is made from 4 shaded squares. Calculate the perimeter of the shape. So we have this length of 15 centimeters, and we can see that 15 centimeters is the same as the length of 3 squares. So because 3 square lengths make 15 centimeters, we can find 1 square length, so the length of a square, by dividing 15 by 3. So that gives us 5 centimeters. And because we have squares, we know that all the lengths will be the same. Now the perimeter is the distance around the outside of a shape. So we know that this length is 5, this length is 5, so is this length. So basically what we can do is write 5 next to all the lengths of the squares. And because we've written 10 fives, 10 times 5 is 50. So that means this shape has a perimeter of 50 centimeters. 23 times 36 equals 23 times 9 times something. So here we need to recognise that we can use factor pairs to multiply. So 36 is the same as 9 times 4. So rather than multiplying 23 by 36, if we multiply 23 by 9 and then take our answer and multiply that by 4, we'll get the same answer as 23 times 36. So our missing number is 4. A machine only takes 20p coins. The coins inside total £9.80. How many 20p coins are there? So £9.80 is 980 pence. So because we have 20p coins, what we can do is divide 980 by 20, and that will tell us how many coins there are. So with division, when we have end zeros in the question, we can cancel them, and 98 divided by 2 is 49. if we're not sure of that mentally, we could use short division here. So there are 49 20p coins. The other way to solve this question is by counting up. So if we have 20p coins, then 5 coins will equal £1 because 20 times 5 is 100 and 100p is £1. Then if we times by 10, 5 times 10 is 50, 1 times 10 is 10. So we know that 50 coins would be £10 and £9.80 is just 20p less. So that means that we have 49 coins.